All right, so today we're going to take a look at properties of numbers, specifically real numbers. So if you want to put the word real in like I did, that's great. If not, it's not a big deal. We're only working with real numbers right now anyway. But we are going to look at the properties of real numbers today. And as we take a look at this, there's a couple of sort of definitional things, one in particular that we need to make sure that we all are thinking the same way about, and that is the phrase like terms. So we consider terms like terms if they have the same structure. So what do I mean by structure? Well, it would have to be the same variable, and if the variable has an exponent, the exponents would also have to be the same. They have to look alike. They don't have to look perfectly identical, but almost, at least in terms of the variable component, the variable components have to be identical for them to be like terms. So the first one, 5D plus 2D, those are like terms because they both have the same variable, D, and neither of the D's have what we see as an exponent. Or we could say they have an exponent of 1, if you want to think about it that way. Okay? So those are like terms. So what does that mean? Well, it means that I can combine them. And I can combine them just like I could combine the 5 and the 2 if it were just 5 and 2 standalone. What would 5 plus 2 be? 7. So this one's also going to have a 7. And it will be 7D, because the others were also D. Those are like terms. On number 2, they all have Y in them, but they are not all like terms. Which two are like terms? Yeah, 3y squared, 2y squared. What makes them different than the one in the middle that I didn't underline? The squared, right? So I cannot combine a y squared with a y. And if you want to think about it this way, when we square numbers, you think about measuring lengths and measuring areas. When we talk about the length of 5, I don't know why I picked 5, but I picked 5. The length of 5, you're measuring like how tall somebody is. They're 5 foot tall. You're measuring how far you can jump. You can jump 5 feet out. You're measuring your wingspan, maybe it's 5 feet long. Okay, so you're measuring something in a linear way. But when you multiply 5 times 5, that's representing a square area, right? It's area. So I can't add area and length together. So when I have the y in there, it's like a length measurement. And when I have y squared, it's an area measurement. And we would never say, I'm going to add the length of the room to the area of the backyard. You're like, why would I do that? That wouldn't make any sense. That wouldn't give me anything that makes any sense. So it's the same idea. So 3y squared and 2y squared can be combined. What will they equal if we combine them? 5y squared. And then the other piece that's not a like term has to simply stay separate, plus y. Okay. I know you guys have been doing this forever. I get that. It's been a long time since somebody talked to you about this the first time. But it's also easy to just make a mistake and start combining things that aren't really supposed to be combined. Forgetting when we're multiplying and forgetting when we're adding and combining things that don't really combine. We're going to keep working more in this as we move on into the properties of real numbers. But there's going to be a lot of writing on the next few slides, okay? So please don't get ahead. Just write number. I've got seven properties we're going to list. Please just list the first property because right after we list it, I'm going to give you an example of what it means. And if you all just write everything down, you may run out of space to give your examples. So don't get ahead. Just do the first one. Okay. Properties of real numbers. The first property, the only thing I want you to write down, commutative property. Okay, this is the only thing you're writing down from the slide so far. Commutative property. Okay, so what does the commutative property say? Well, in order to even kind of talk about this, I'm going to use A and B and C, and these are going to be real numbers. Okay, real numbers A, B, C. So if I have the commutative property, what the commutative property has is two components. One component says that A plus B is equal to B plus A. The other component says that A times B is equal to B times A. Now, of course, addition and multiplication are not the only properties we have. We have subtraction and we have division, but they don't have this property. So let me just kind of show you what I mean by that. It's actually not true that A minus B is equal to B minus A, right? That's not true. Neither is it true that A divided by B is equal to B divided by A, at least not in general, okay? So this is specific to addition and multiplication. Doesn't work for the other operations. But you know that this is true, right? 5 plus 2 is 2 plus 5. It's one of those things that when children are first learning their multiplication tables or their addition tables, they get easier as they go because you're not adding very much on. So usually you learn, we'll talk about addition, you learn all your plus ones, right? Everything is 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4. And then when you get to the 2 pluses, well, you already knew the 2 plus 1 part, so you have fewer of the 2 pluses to learn. Once you get up to the 8 pluses, I already know what 8 plus 1 and 8 plus 2 and 8 plus, I already did all of those. I only have to know a few more, right? Because the commutative property allows me to reverse the order. And it does it for addition and for multiplication. Okay, write the second one down, associative property. Oh, one more thing about commutative property. You don't need to write anything, but just for me to say it. You can think about commutative as the idea of commuting, right? So does anybody in here commute to and from somewhere you don't live on campus? Okay, a couple of you. So if you were to talk about commuting, it's the same if you tell me how long it takes you to get from where you are to campus or where you are from campus back. We never talk about it in terms of negatives or switching the order, right? It's always talked about in the same way. You're switching the order of where you are commuting. All right, associative. The associative property has to do with what's associated together. So I am going to show you again, this only works for addition and multiplication. If I have A plus, and then in parentheses B plus C, this is the same as having the A plus B and then adding the C. So the groupings of additions don't matter. And the same is true for multiplication. A times B times C would be the same as AB times C. Those are actually really cool facts. And the reason they are is because sometimes it's easier to add B and C together first and then add A to it. For example, if I had, you don't need to necessarily write this down, but I want to justify for you what I'm talking about. If I have 5 plus 3 plus 5, you might like to add the 5 and the 5 together first. Why would that be friendly? Because it makes 10, which is almost like a single digit number, right? So there might be reasons to group things together, especially as the numbers get bigger. So you might look at that and say, well, all those were really simple numbers, Dr. Hands. It really wouldn't matter. And you're right, it really wouldn't. So what if instead they were, 15, oops, I meant to do purple. Let's try it again. 15 plus 33 plus 5. Now I really don't want to add the 15 and the 33 together. That does not sound like my best choice, but adding 15 and 5 together would be nice because I get 20. I get one of them being a 0, right? So there's sometimes really good reasons for choosing to add which values together first. The commutative property allows me to redo the order. The associative property allows me to add any two numbers together that I want to before I add the third one. All right? So that's associative property. Again, I'm not going to tell you this I'm not going to write it out on every single one, but if I try this with subtraction or if I try this with division, it doesn't work. All right? It doesn't work. This is only a property for addition and for multiplication. All right, the additive identity. You'll notice that the next two properties have the word identity in them. Okay, so the additive identity is the number 0. The multiplicative identity is the number 1. So what does it mean to be an identity? Well, it means it operates on other numbers so that it doesn't change things. So this is the the additive identity because A plus 0 and 0 plus a, leave a unchanged. It's the identity. It doesn't actually change the value. The multiplicative identity does the same thing, but with multiplication. 1 times a is equal to a times 1, which is equal to a. So an identity is a value that doesn't change things. Now you might look at that and think, I mean, but why would I ever want to multiply by 1? If it doesn't change anything, what good is it? And that's a valid question, except that you've actually already been using it. You've been using it when we talked about fractions. When we took 2 over 3, and for whatever reason we were adding it to something or whatever, we multiplied the top and the bottom by 2. Why are we allowed to do that? Well, because what's 2 over 2? 1. It's the value 1. That's why we're allowed to do that to fractions. And that's also why I mentioned at the beginning of class last time that I wanted you to make sure you're writing it as 2 on the top and 2 on the bottom as multiplication and not just times 2 to the whole thing. Okay? Because multiplying by 2 over 2 is the identity. It's really just multiplying the fraction in that case by the number 1. Okay, we've got a few more. Go ahead and write down number 5. It's the additive inverse. The additive inverse says that for every number, we have its opposite. And when I add a number to its opposite, what do I get? I get 0. And it works in, again, whatever order I add them because addition is commutative. So the additive the additive inverse says there's always a number that I can add to something and get back to 0. And that's really good because when we were solving equations and trying to move numbers around, if I have y plus 2 equals 7, the reason that this one of the places where this comes into place is because there's a way to get this 2 to go away because it has an additive identity. I'm sorry, I keep saying them backwards. An additive inverse. I can add something to it and get back to the identity of 0. So this actually equals 0, and that's what the additive inverse does for us. Every number has one. So what's the additive inverse of 4? Negative 4. What's the additive inverse of negative 2.7? Positive 2.7. Okay, so just for the sake of having said so, what's the additive inverse of 0? It's 0. Kind of a weird one, but it technically exists. It's just not super useful, right? Okay, multiplicative inverse is the same idea. There is one caveat. The multiplicative inverse won't exist for 0 itself. 0 doesn't have one. So this is going to be true for all values that are not equal to 0, okay? 0 does not have a multiplicative inverse. But everything else does. So multiplicative inverse says that for every value, I have a reciprocal, and when I multiply them together, I get back to the identity of 1. And we actually already looked at that. We didn't look at it from this perspective, but we talked about this already, reciprocals, right? Yeah, we did. So this actually works, and again, in either order because multiplication is commutative. So any way I multiply it, I'm going to get back to the value 1. And again, every number has one of these, just like when we talked about reciprocals, except for 0. 0 does not have a reciprocal because 1 over 0, 1 divided by 0 is undefined, okay? So we don't have an identity for 0, multiplicative identity, multiplicative inverse. Somebody's going to be listening to this video later and they're going to be like, what is wrong with her tongue? She can't say identity and inverse in the right place. Multiplicative inverse. Okay, one last property, and this one is where we're going to spend the majority of our time today because a lot of the problems are going to have this in it anyway, is the distributive property. And the distributive property says that if I have a number with a set of parentheses next to it, either addition or subtraction inside the parentheses, doesn't matter. While, yes, if I can simplify inside the parentheses first, I should, sometimes I can't. sometimes this B and this C inside there are not like terms. They cannot be combined. And if they cannot be combined, is there anything else that could be done? And the answer is yes. This value on the outside can be distributed through the parentheses. So this becomes A times B, and then the same sign, whatever it was, plus or minus, and then A times C. And it works from either side of the parentheses. So if this had been B plus or minus C over here, and the A on the back side, or the, following it, we can still distribute this way as well. The order doesn't really matter, so if you want to still write down AB, you can. If you want to write down BA, that's cool too. But the distribution works from the back side as well as from the front side of the parentheses. Okay, so talking about properties is always kind of boring. And I think part of the reason why is because you're so comfortable with most of them, you use them without even recognizing you're using them. I mean, that's what's really happening. Let me actually go back to the first example we did today. This is it. This example right here actually used the distributive property, and you didn't think about it even kind of. And here's why. What do 5D and 2D have in common? The D. This is another way of writing that, sort of the undistributed version, right? And what's 5 plus 2? 7. And that's actually why these like terms are able to be combined, is because of the distributive property. We just don't think about it that way, okay? But they're in play all the time when we're combining things. So we're going to do some examples of this. I have 3 problems on the board. I would like for you, I really don't want to just sit up here and talk. So here's what I'd like for you to do. I would like for you to do the 3 problems and then to compare with a neighbor. And then I would like a volunteer, and I'm going to send the iPad around. I'll stand beside you if you need to make sure you're not going to screw it up or something. And I would like for you guys to have a chance to write in on my iPad what's going on. Okay? So first, 3 problems. Work them out. Check with the neighbor. Anybody need a stapler still? As you finish up, turn to a neighbor, compare your solutions, compare the answers you got, how you did them. Volunteer for me?
Yeah.
Thank you. Macy's our first volunteer, and willingly and everything. I didn't even coerce. So this is fantastic. Okay, so Macy's gonna explain, or gonna do this one.
It's gonna be real embarrassing.
I'm just gonna explain as I come to you if you're using it, so that you can see. So we can make it bigger, so that you can still write.
Okay.
You can use your finger. You can use the tip. You can use this tip or this tip, whichever you feel comfortable with.
That's awesome. I can use this.
Yeah.
Bruh, that's
You can't
awesome.
touch the screen, though, while you write, so you have to hover.
Okay, so then... Okay, I guess I'll do this one. So I got...
It'll be easier if you set it down.
Oh.
I'm just going to tell you. There you go.
So I just... Oh, that's a terrible line, but it's okay.
It's okay.
So I got... But I probably did that wrong.
Is that what you guys got? You did not do it wrong, Macy.
Oh,
That's
thank God.
perfect. Very well done. All right,
It's
need
like
another
so
volunteer.
simple.
Who wants to write on there again? Okay.
It's so simple that you overthink it.
Yes, you can. Okay, so, oops. So again, this is going to be fun when somebody watches this later. I'm making the screen bigger so you can write in a bigger size.
Okay.
You can use your finger, you can use this tip, or you can use this tip. Any of those you like.
This
to
one
write.
I can touch the screen, right?
You can't touch the screen at all, no matter what you write with your hand. You have to hover.
Wow.
Okay. Because the screen is touch sensitive on this particular program.
Why is it not? Oh.
There you go.
My bad.
See what I mean?
Done.
Very good job. All right, does everybody get 3x minus 6? Yes? Wonderful. Thank you so much. Okay, so I'm working on names. Sarah. All right, so we had Macy, we had Sarah. Who wants to do the next one?
Do we get extra credit?
No, you don't get extra credit. You get the fun of having used my technology for the day. I don't care if your handwriting's horrible. We can all read it. It's good. All right, I need another volunteer. I will volunteer people if people don't start volunteering. All right, so we're going to let Megan do it. Okay, again, we can make the bigger size, and then you can use the tip, either one, or you can actually write with your finger.
Okay.
Okay. Yes?
Yeah.
Yes, thank you so much, Megan. All right, that is the correct answer. Okay, you guys ready to try some more?
Yeah.
Okay, I've got 2 more for you. We're going to do the exact same thing. 2 more problems. You're going to work them out. You're going to compare with the neighbors. So this is what we have. They're getting a little harder. Yeah, I know. You saw a fraction, didn't you? That was the... Oh, I just heard. I know. You'll be okay, I promise. I am sure about that, Preston. Stuck, you can turn your neighbor as well. Okay. Okay, those of you who are at the back of the room, are you still talking to people around you? Checking in with Cedric? And, you know, you guys are kind of a little bit of a distance, but make sure you're chatting with somebody.
I assume you did 3 first, and after that, I do it again. Because it's not the same water. So I should do the 3 first, so I guess 3y plus 18.
That's exactly what I these aren't multiplied, this is subtraction of y. Not multiplied. Is that why? Like if you try to so it's 3y minus y. If you distribute it,
Break down into
you don't need the parentheses anymore. Once you've distributed through there, the parentheses are no longer a part of the process. Yeah, but then you need to combine. Are there like terms? Yes. Which terms are alike? Right. It would be like a 1y, so 3y minus 1y. 2y plus 18, right? Okay, so Preston just volunteered for number 5. Who wants to volunteer for number 4 for us? All right. L'Oreal's going to volunteer for number 4 for us. Okay, and I agreed. Number 4 has the fractions, right? So if you made a mistake, it's okay. We'll get it fixed. But let's check out what L'Oreal had and start there. Okay, so you can use either tip on the pen or you can use your finger. And we can make it a little bit bigger, but you can't touch the screen with your hand while you're writing, so you're going to have to hover, okay?
Let me see.
Okay, so pause right there for me a second. Does everybody see where that came from? Okay, that looks great. Good job. Okay, so she's distributed the 12 through. When you distribute the 12 through the 2/3, the 12 only applies to the 2, right? Because it's 12 over 1. Yep. So the 12 applies to the 2. The 1 would actually apply to the denominator, the 3 that's there. Okay, and then we have one more step to clean it up, right? Simplify, L'Oreal. What you get? Lovely. Very well done. 8 plus 24u. Good job. They told you we'd survive. And we did, right? We did.
Where does the 8
24 divided by 3.
Okay.
Yeah, it's just simplifying this piece. And it wouldn't necessarily have to simplify, right? It could have been something that like 17 over 3 when we were done or something like that maybe. And then we would just stop. But this one actually could simplify. Okay, Preston got my help on number 5, so he gets to show you what we did, right? Okay, so you can't touch the screen. You have to hover your hand when you write, which is a little awkward. And that's actually the side of the pen that I think easier to write with too.
So do these.
Okay. Did you guys get this as your answer? Okay, that's good. I'm going to make a couple of changes to Preston's work so that you can see what I would like to see when you're doing your homework and your tests and things like that. So here's an error that I see a lot, and it's not really an error, it's just notation of how you're writing it, okay? What this actually says is that 3y minus y equals 2y plus 18. That's not really what you meant, right? No, you meant what my son said to me the other day is that he kind of thinks about it equal signs means and the next thing is. And the next part is. We do that a lot. I know it's really common. So instead, what could we do? Well, right underneath it would be good. Yeah. The other thing we could do is we could actually put your plus 18 right here. And then if you did want to put the equal sign, it'd be okay. Because then they would be equal, right? So when he moved the 3y and the negative y to be sort of together, what operation allowed him to do that? I mean, you may not have written it out like he did, but what operation allows you to do the 3y and the y together? The associative property allows you to regroup, and the commutative property allows you to change the order. So it's both of those, right? That's the commutative and associative property at play, allowing us to regroup things in a different order because they're like terms, right? Yeah, Excellent. Okay, we got 2 more. You ready? Okay, you guys are already starting to turn to neighbors. That's awesome. As you finish, take a look at what you have and compare. Haley, are you good? Okay. Devin, you're good? Excellent. You guys good over here? You think? Okay. All right, so I haven't had anyone in this area of the room volunteer yet. So I need a volunteer from over here. Who wants to volunteer from? All right, and it's Connor, right? Okay. All right, Connor's going to do number 6 for us. Okay, so we can make the screen bigger so that it's easier to write on the size-wise.
Okay.
You can use either tip or you can use your finger to write with, whatever you feel comfortable with. All right, so Connor's going to write down what she has. As she does, check and see if yours matches.
Do you have to press harder? I was
It's
like,
probably my fault, I'm sorry. Okay, give it a try. There you go. Good job. Okay, pause for me, Connor. Everybody good at that step? Yeah? Awesome. Okay, and keep going.
Okay.
All right, so when we get to that step, she's looking for like terms. So the 4K at the beginning and the negative 2K at the end would be like terms. Positive 4, negative 2 give me a positive 2K. And then the numbers in the middle are also like terms because they're constants, no variables attached to them at all. Negative 28,
Positive 12, we've already talked about integers, that would give us negative 16. Okay, thank you, Connor.
Yeah.
All right, another volunteer. I'm still sticking with this corner of the room. Kaylee, you want to do it for me? All right. That was almost a volunteer. I kind of volunteered her. Okay.
Yeah, and I've made it kind of bigger, so you can write as your normal size, and then you can use either tip side, or you can use a finger to write with.
Okay, no parentheses on this one, right? So we're not distributing anything. Very good. All right, so on this one, all we're looking for really are the like terms part of it. Thank you very much. And just so that we're all clear, if you don't want to actually shift things around like McKaylee did and like move them, this middle step, you don't have to. It's okay. But it does help to collect the things in your mind at the very least and figure out which pieces go together. The other thing that's sort of standard form, but it's really not that important either, is that a lot of times you'll see starting with x squareds first, and then x, and then the constant term, it's called descending order of exponents. If you do that, that's great. If you don't, it's not a big deal. It can go in a different order. Yes, Preston?
So like kind of thing like I did when I worked it out.
Mhm.
It's like I put like different symbols around like each of the different terms.
Okay.
So like, I was like putting this together.
Sure. That's fine. Yeah.
Like if I do that on my homework, I'm not gonna cut it off for it.
Nope, that's fine. You're just grouping them together in a different way. One of the things that I've also done when I've done problems like this, hang on just a second.
Yeah, can I show you like what I did?
Yeah, is that I will mark them differently, like this. These two go together.
Yeah, exactly.
Yep.
Like that.
Mm-hmm. And then maybe I just underline this one twice. These two go together.
Yeah.
And then these two go together, something like that. Sure.
Yeah, exactly
Mhm.
like that.
Yep, it's a good way to do it. You're just organizing them in a different structure. Okay, all good. Jack.
Okay, so negative 4x and negative 3x, would that become a positive?
Ah, it's a good question. If we were multiplying them as negatives, they would become a positive. But we're not multiplying, we're adding. So if you think about the numbers themselves, the -1 and the -3, from a number line perspective, -1 would be here, and then -3 would put us further back over here at -4. So that's what's happening. Good question. Any other questions?